Hello, in this video we will talk about how to solve a system of equations using the numerical method. So what is a system of equations? It's basically a set of equations that work together. So this would be a set of equations that combined will describe a certain situation. So when you have only linear equations in a system, then that system is called a system of linear equations. And if your linear equations have only two variables, then that would be a system of linear equations in two variables. So this video would actually talk about a system of linear equations in two variables. So here are two examples of equations, system of linear equations in two variables. So you can see in both of the examples, the equations are linear. There are two variables and then there are two sets of equations. So in order to solve a system of linear equations in two variables, you will need at least two equations. Now, what does it mean to solve a system of equations? It means to find a point which satisfies both equations. There could be more than one points as well. So for example, we have this set of equations, y is equal to 5 over 2x plus 1 and y is equal to negative 3 over 2x plus 5. And we say that the solution to this system is the point 1, comma 3.5, and the reason for that is that that point will satisfy both equations. So let's try that point in the first equation. So if I replace in the first equation the x by 1 and then I start solving it, what I find is that that comes out to be equal to 3.5. So we have that point 1, 3.5, and we know that that point belongs to the first, to the line represented by the first equation. Now let's also do the same thing with the second equation. Let's substitute x is equal to 1 in there, and let's solve for y. And again, what we find is we find 3.5. So we have this 0.1, 3.5 on the second equation as well. So the 0.135 will satisfy both of those equations, and that's why we say that this is the solution to this system of equations. Now, how do you solve a system of equations? There are some methods. So first is graphical method, where you just draw the graph of those two equations, or more equations if there are more equations, and see where do those lines intersect. Next is the numerical method. This is what this video is about. We'll talk about numerical method in a second, how to solve using tables of values. And then there are algebraic methods. So you could use algebra either in substitution or in a method called solving by elimination. So this video is about the numerical method. So let's dig into the numerical method. So this method will use tables of values to solve a system of equations. Let's take an example. So here's my system of equations. Y is equal to 2x plus 7 and y is equal to 5x minus 3.5. So what you would need to do is you would need to set up a table where the first column would be x, the second column would give you corresponding values for y for the first equation, and then corresponding values for y for the second equation, and then you would find the difference in y. So let's start by putting x is equal to 0. And what we find is when x is equal to 0, then 2x plus 7 is equal to 7 and 5x minus 3.5 is equal to negative 3.5. Now look at the last column, which is the difference in y. And when we subtract negative 3.5 from 7, we get 10.5. The objective is to get this last column to be equal to 0. So let's try some more values of x. So when you put x is equal to 1, 2, and 3, what you find is that the corresponding values, the difference in y becomes 7.5, 4.5, and 1.5. And you can see going down the table that we are getting closer and closer to 0. But when we put x is equal to 4 in there, then the value becomes, the difference in y becomes negative 1.5, which means that we crossed the 0 that we were looking for. So in the next row, what we're going to do is we're going to find a value in between 3 and 4. So let's try 3.5. And when we do put x is equal to 3.5, substitute that into both equations and then find the difference in y, we find that the difference comes out to be 0. So that means that the point 3.514 is the solution to this equation. So we have the solution here because the value of x and the corresponding value of y, which will make the difference equal to 0. So here's another example. We want to use a table to numerically find the solution to this system of equations. So first thing we do is we set up our table. Again, the same columns, x and the first equation, the second equation, and difference in y. Let's start with x is equal to 0. And when we put x is equal to 0 in both of those equations, we get y is equal to 177 and y is equal to negative 65. The difference is 242. So we try another value of x. Now, because the difference was so large, what we would do here is count up by 5. And now, when we go from x is equal to 10 to x is equal to 15, we notice that the sign has changed. So the value of x, which will make this difference equal to 0, lies somewhere between 10 and 15. So let's try 11. And when we use x is equal to 11, the difference in y becomes 0. So the solution to this equation would be x is equal to 11 and y is equal to 78. So there we have our solution. Let's do another example. So here's my system of equations. Y is equal to 2x minus 8 and y is equal to negative 4x plus 28. Again, start with a table. And first column is x, second column is y is equal to 2x minus 8, next column is y is equal to negative 4x plus 28, and the last column is difference in y. Let's start with x is equal to 0, and x is equal to 0 gives us a difference of negative 36. Next we try x is equal to 2, and then x is equal to 4, and then x is equal to 6. And what we find is that the difference is gradually getting smaller and smaller and smaller. So first, when x was 0, the difference in y was negative 36. When x was 2, the difference in y was negative 24. When x was 4, the difference was negative 12. And when x is equal to 6, the difference is 0. Remember, your objective is to get difference in y is equal to 0. So the solution to this system of equations is the point 6, 4. Okay, here is another example. So we have y is equal to 2 over 3x plus 1 and y is equal to negative x minus 9. And we start with the table. So here's the table, the 4 columns, x and the first equation, the second equation, and then difference in y. Let's start with x is equal to 0. So when we substitute x is equal to 0, in the first equation we get y is equal to 1. In the second equation we get y is equal to negative 9. And the difference 1 minus negative 9 is equal to 10 for x. Now when we substitute x is equal to 2, what we find is the first equation gives 7 over 3, second equation gives negative 11, and the difference is 13 and 1/3. So instead of getting closer to 0, what has happened is we've actually moved away from 0. So now instead of increasing the values of x from 0, what we would do is we would decrease values of x from 0. So instead of 2, we will try negative 2. And when we make x is equal to negative 2, what we find is then that the first equation gives negative 1/3, y is equal to negative 1/3. The second equation gives y is equal to negative 7. And the difference is now 6 and 2/3. So the difference is now closer to 0. Remember, we want to make the difference equal to 0. Next, we try x is equal to negative 4, and the difference comes out to be 3 and 1/3. But when x is equal to negative 6, then the difference is 0. So what that means then is that the solution to this equation is the point negative 6, negative 3. So here's the solution. So now I'm going to summarize the whole process in steps when you want to solve a system of equations numerically. So first step would be to set up the 4-column table. The second step is find y values for both equations when x is equal to 0. Step 3 is decide by how much you will increase x for each row. So if you find in the first row that the difference in the y values is large, then you can make relatively larger jumps. You could count up by 5s or 10s depending on how big that interval is. However, if you find that the difference between the two values is small, then you can increase by 1 or 2. So you decide by how much you will increase x for each row. Step 4 is you fill the table until difference in y becomes 0, but in case you find that the difference between y values is getting bigger rather than smaller, then you would need to change the direction of x values. So instead of increasing the x values from 0, you would start decreasing the x values from 0. And finally, you would write the solution as an ordered pair. Well, I hope that you enjoyed watching this video. If you would like to send us a feedback, please hit the like button and then see if you can subscribe to our channel so you never miss a video. So have a good day, and I hope that you learned something today.